Have you ever stopped and really thought about what's actually happening under the hood when you type a URL into your browser and hit enter? Well, today we're going on a little journey. We're going to dive into a developer's personal notes as they figured out the core protocol that powers, well, the entire web, HTTP.
And look, this isn't going to be some dry textbook lecture. The whole reason we're doing this explainer is because the source material is a developer's actual learning journal. So we get to follow along with their questions, their moments of confusion, and, most importantly, their breakthroughs. It just makes the whole thing so much more relatable and, honestly, easier to grasp.
And it all kicked off with this one simple-sounding question. It seems basic, right? But the answer? Well, the answer is way deeper than you'd think, and it's changed so much over the years. This question is our launchpad, so let's get into it.
Okay, so first things first, let's make sure we're all starting from the same place and get the absolute basics down.
So, at its core, what is HTTP? Well, think of it as just a rulebook, a shared language. It stands for Hypertext Transfer Protocol, which is really just the official set of instructions for how a browser, the client, asks a server for something and how that server sends it back.
Now, to make all this technical stuff stick, we're going to use a really simple analogy that the developer came up with, a coffee shop. In this scenario, you are the client and you want a web page or a coffee. The barista is the server, the one who has what you want, and your order, that's the HTTP request. Simple enough, right? Let's see how this plays out.
Because the way you order that coffee has changed a lot. We're going to break down the 4 major eras of HTTP and see how each new version was built to solve a really annoying problem from the one that came before it.
So we start way back in 1991 with HTTP/1.0. Super basic. You want something, you open a connection. Done. Then, in 97, we get HTTP/1.1, which introduced the Keep Alive connection, a huge deal at the time. Then we fast forward quite a bit to 2015 for HTTP/2 and its killer feature, multiplexing. And most recently, HTTP/3, which kind of rebuilt the foundation with something called Quick.
And this is where that coffee shop analogy just makes it all click. HTTP/1.0 is like you order a coffee, the barista hands it to you, and then immediately slams the window shut. If you want a muffin, you have to knock all over again. HTTP/1.1 is better. It keeps the window open for your next order. HTTP/2? Now that's like having 10 baristas behind the counter working on all your orders at the same time in parallel. And HTTP/3, well, that's like being able to order perfectly even if you're standing on a shaky rope bridge with spotty cell service. It's built on a protocol called Quick, which is just smarter about how it sends data. So if one piece gets lost, it doesn't stop everything else. A total game changer for mobile.
Now, let's really zoom in on that one massive problem that slowed down the web for nearly 2 decades, and the big idea that finally fixed it.
This was the developer's big aha moment. And it's a fantastic question. I mean, why is it such a big deal to reuse one connection? Well, the answer is that starting a new connection is surprisingly slow. It requires this thing called a TCP handshake, which is like a digital secret knock and password exchange that has to happen every single time. Now, imagine a web page needs 50 different things: images, scripts, CSS files. Doing 50 separate handshakes would make that page load at a crawl.
So HTTP/1.1's Keep Alive trick was a step up, but it created this new kind of traffic jam called head-of-line blocking. See, even though the connection stayed open, it could still only handle one request and one response at a time, in order. Back to the coffee shop, if your first order is some super complicated 5-step latte, your friend's order for a simple black coffee, right behind yours, has to just sit there and wait. That's HOL blocking in a nutshell.
The process was just this rigid one-by-one queue. A request for a giant image file had to be sent, processed, and fully delivered before the browser could even ask for the tiny CSS file it needed next. You can just feel how inefficient and slow that is. It was a huge source of sluggishness on the web for years.
And then, along comes HTTP/2 with its absolute superpower, multiplexing. This just completely shattered that old one-at-a-time model. With multiplexing, the browser can just fire off all of its requests at once, over that same single connection. The server works on them and sends back little pieces of each response all mixed together. That slow latte order doesn't hold up the simple black coffee anymore. Everything happens at once.
Okay, so this is all great in theory, but how does knowing this stuff actually help you, as a developer, with a real problem? Well, let's see how this knowledge helps us solve mysteries right inside our own DevTools.
A classic. You open up Chrome DevTools, you look at your network waterfall chart, and you see that a request was stalled. Your gut reaction is probably, oh man, something is wrong with my front-end code, I have a bottleneck. But with our new understanding of HTTP, we know to dig a little deeper. So our developer did just that. They dove into the detailed network timings and found the real culprit, a high time to first byte, or TTFB. In this case, over 80 milliseconds. Now that number told them that the problem wasn't the browser being stalled. No, the server itself was just slow to even start sending the file. The problem wasn't on the front end at all. It was on the back end. Huge difference.
And hey, you can check this on any website you want right now. Just pop open your DevTools, head to the Network tab, and right-click on one of the column headers like Name or Status. You'll get a little menu where you can check Protocol. That'll add a new column, and you can instantly see if a site is using the modern H2 or the older HTTP/1.1. It's a tiny check that tells you a whole lot.
What's really wild is that this knowledge actually affects the big decisions we make about modern JavaScript frameworks. Believe it or not, the protocol your server is running can make one framework strategy way more efficient than another's.
Take, for example, a classic React app made with Create React App. It bundles all of your code into one giant JavaScript file. Now, back in the HTTP/111 days, that was a great strategy because it minimized the number of requests. But then you look at a framework like Next.js, which loves to do code splitting, breaking your app into tons of small little files. That strategy would be awful on HTTP/111. It absolutely relies on the multiplexing power of HTTP2 to load all those tiny files super fast. It's a perfect example of how this low-level protocol stuff has a direct impact on high-level architecture.
So let's bring this all home. Why did our developer feel like this was something they absolutely had to master? Why is it so important?
Because without understanding this evolution, you're basically flying blind when it comes to web performance. You won't get why your perfectly clean code is still slow. You'll totally misdiagnose network problems like that stalled request, and you won't really understand the trade-offs of bundling versus code splitting. As the author put it, this stuff isn't optional. It's foundational to being a modern web developer.
And what's so cool is that once you get a solid handle on HTTP, it's like you found the key that unlocks the door to so many other critical web concepts. Things like security with HTTPS, those dreaded CORS errors, authentication with cookies and JWTs, caching, all of it is built directly on top of this foundation. It's the real starting point for a much, much bigger journey.
And that is the perfect note to end on. You're never really done learning, right? But by really grasping these core principles, you get a completely new level of confidence. You're not just using tools blindly anymore, you understand the fundamental rules of the web. So the only real question left is, what bottleneck in your own app are you going to go find and fix tomorrow?